Okay, and good morning to everyone. And I believe that was the cranberries and Sunday? Okay, it's Sunday even though it's Thursday, but we're getting ready for Sunday. And we have a holiday coming up, just to remind you. On Monday and then Tuesday's the biggie. We have to be in school, but that's the inauguration. For those of you who are just can't wait to work with negative numbers, it is cold back there. Got a text message from my son in Minneapolis, minus 20, wind chill at minus 35. I checked the farmhouse in Iowa. They're starting out at minus 9. The high will be minus 1. Is that cold enough for you? With wind chill advisories, don't go out with your face uncovered. You'll get frostbite. So, welcoming everybody to Math 20. Those of you who are watching from sunny California, we're in our 70s here with the summer-like weather. Those of you down at Palomar watching there, I'm sure you're even doing better than we are. Maybe it's time for golf, barbecues, and the usual activities we think of in the summer. We are dealing with a pre-algebra, and there are a number of issues I want to talk about. The first, I did go ahead and open up the time frame so that you could continue working today and getting the problems entered into the computer program for the homework. I shared with Sarah some of your frustrations, and so that was dinner topic for us. And she went ahead after dinner and she went online and tried the section problems we were talking about, and she couldn't get it to malfunction. That doesn't mean it didn't malfunction for you and get repaired or whatever. But the question, were you still having troubles today putting your answers in and getting it to accept it and everything was okay? Now what usually happens, if somebody has trouble, and I don't have that luxury here because during the class time I can't respond and I go to another class immediately and my day is such that by 4 o'clock in the afternoon I finally can do something about it. But if other people are using the text and people are running into problems, they forward that information to my math lab and they make adjustments quickly. So, Sarah suggested patience, tolerance, smile a lot, and think positive thoughts. So, I think we will continue with that model and with the idea that things will get smoother. And if you're comfortable with it in 1 week, doesn't do it in 3 or 4 days. But I'm hoping as we go through this week and next week that you get a comfort zone and you can say, yeah, this is pretty good. I want to, this evening, sit down and look at how things went for you, how the grades look. I haven't had a chance to do that. I was working from 4 to 5, well, 4:30 to 6 on email to everybody trying to respond to that today. And so I have not taken time to do anything with my math lab. A couple things, though, that are related to that, and I want to do. One, I don't feel there's a good enough sense of accountability for what I want you to get out of the course. So I'm going to institute a slight variation here, and then I need to talk about tomorrow and what is or isn't happening then, and then the whole idea of quizzes on Fridays, which seems to be a bit of a problem for schedules and such. But first, with relation to the homework, this is a discussion I've had with a couple of you. And it has to do with what you gain by writing things out. So, I've asked you to have a notebook that you write your solutions in as you do the problems and then you enter them. I think what we're going to do is a weekly follow-up to that. At the end of each week, I want you to sit down with Larita and have her check through your notebook and see that you've been doing the problems and see if there are any questions, and she will sign off each week. And you can do that either at the tutorial at 9 to 10. And one of the things, I guess in terms of the tutorial at 9 to 10, probably works better in the library because that's where you're meeting, or you're meeting in the trio lab. Library? Does that work out okay at this point? When the what? When there's computers available. Not always the case. Okay, that's a wrinkle that I hadn't thought of. Okay, let's think in terms of this. If it turns out that the computers just aren't available, this room after my 8 to 9, we're done in here by 9:15. We could use this for a tutorial if you just want to sit down with people, work at tables. I will try to take a break because I will have gone 2.5 hours nonstop at that point, would like to take a break briefly. But we can use this room for the tutorial if that will work. So if you hit the library and it's just no dice, then just get everybody over here and we can do a tutorial in-house, and I'll just adjust the date things are due so you have time to get on there. I think the biggest mistake I made was trying to do it 10 a.m. the following day because the computers aren't always available that way and it's not providing enough time. So I will make it a point as I adjust the times next week, maybe giving at least 2 days after the assignment so you can get it done. I hope that'll help. But what you're obligated to do is, and I'd like to start with the idea of whatever you've done this week, I want you to have that in a notebook, and by tomorrow, today, sometime, I want Larita just to look at it. You don't need to check problems. You just need to see, okay, the problems are shown, work's done, and then just have a sign-off part at the front of the notebook. And I'd like that to be done each week. And when we get to a test, then I'd like to be able to look at those notebooks and say, okay, I'm feeling comfortable. I think the key here, if you write things out and you do them, I think you gain more than if you just in your head do something. And that's what I'm trying to encourage. Now, Michael, as you stick a brownie in your chops, I'll go on if you want me to wait a moment.
No, I've been writing. I haven't been keeping my notes. I've lost them.
Okay.
It's like scratch paper.
Okay, so I understand. I will adjust then immediately. Starting next week. Okay. Starting next week, keep your work in a notebook, and we'll have Larita go through it. If you happen to have a notebook that you've been keeping, have Larita check it. So the idea is to encourage you to have something that you've written down that I can go back and look at, and if we get to a place where there's a question and say, okay, well, show me what you did. And I know that you've been doing that on paper, but it would help to keep that organized. And I think that's something that's missing if we don't do that. So again, next week, formally, if you have it done this week and you have it together, have Larita sign off. And let's have a sheet on the front of your notebook where she can sign off each week. Just date it and sign it, and that way we can get a sense of what's going on. Yes, Dion.
You know how you're going to implement extra credit?
Not yet, not yet. The question is about extra credit and how I'm going to. I have no idea at the moment. So far, I'm in survival mode. Before I get that, Marisol, you got a question? Or?
I was just confused that
Thank you, Sandra. Okay. Yes. The question is there any way of making up the first assignments? And yes, I will need to go in, and I'm just going to open that up so that you can work on it this weekend up through Monday. And then hopefully by Tuesday, when we come in, everybody's caught up. Everybody's had as many opportunities as they needed. And I do believe it'll get smoother. We've gone through a rough patch trying to get some things done. And I think it'll go smoother as time goes on. So don't get too panicked yet or depressed about it. I'm hoping that that will improve. Now, part of my concern, and I'm delighted that things are working out in terms of the library at 9 to 10. Now, understand at 2:30 to 3:30, there's an opportunity to either, and this is a problem of, again, seeing if we can get a room where you could work with a computer or have access. And that's something we need to work out because there has to be, particularly if you don't have access to the computer at home and you're fighting this, we need to have some more time available, and that's where the afternoon would work well. And one of the things I think we all need to understand, this first part is so much review from where you've been. I went and looked at the next section, and it's like, okay, we've done all that. So I'm going to highlight it, but there's just not that much that's coming out of this next section other than the idea of a square root. We extend a little bit more, but it's pretty darn straightforward. So part of what I think there's a good side and a bad side, that old sword that cuts both ways. One, the book we chose because it fits so well. I mean, there are just so few places that I have any concern with what we do typically in Math 10, and it's exactly that feeling as I look at 1-4. The downside is you have a comfort zone right now that probably isn't going to be there in the same way a month from now. So things are going really smooth, a lot of review. Your biggest fight has been the computer. As Sarah reminded me last night as I was grumbling, that's probably good that it's so much review for them right now because their only battle is with the computer, and that'll smooth out, and then everybody will be content. I think the wisdom is well stated. But you need to understand that tutoring session in the afternoon could become crucial to you. Okay? So right now, you're skating. And I understand that, and I hope you understand that. And you should be doing really well right now. You should be getting 10s on those. You should be easily getting 100% with a little bit of effort once you understand how to enter things into the computer. But as time goes, and it's not very long, we're going to be hitting some material that I think you're going to need to have an opportunity to drop by the tutoring session. And Loretta was there yesterday, and we had more people helping. We had Marisol there, we had Sandra there, we had Raylene there, I was there. We had a 1-to-2 ratio. 2 students for every tutor. And that's great for them, but you're missing an opportunity if you have troubles. So again, we're skating right now, understand that, and things will get more challenging. Fair enough? Now, other than that, we talk about the homework, where you write it out, have Loretta sign it off on a weekly basis starting next week. But tomorrow, now my intent, and it's not worked, what I had set up, my intent was because we had 10 o'clock, I couldn't do 8 and 9 o'clock on Fridays because we have the Math 10 breakfast and tutorial, and then at 10 was the earliest I could do it. We were having a class then, and so I thought, okay, 10 o'clock's a great time. Unfortunately, some of you have schedules that block you on Friday because you signed up for classes then, or you have commitments to jobs or to the Bridge program as participating in that. So I know that there's at least 4 of you who have conflicts, and that's minimally. Can I just see hands who have conflicts for tomorrow at the time? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Holy mackerel. Okay. I may be lecturing in here all by my lonesome. We're doing this presentation to Palomar and to the rest of the 3C Media Solutions, and to the only thing we aren't doing is showing the broadcast on Friday locally on television because we only have the bandwidth for the television 4 days a week. How many can be here? Let's see your hands. Okay, so I have a small number. So we're going to have a party tomorrow. Okay. I'm going to try to do a tutorial. And so that I can answer questions, we will have a VHS tape of it. So you'll be able to watch the tape. And I'm going to, one of the goals I had, and at this point, and I'm sorry that we're taking time to do housekeeping things, but it's critical to the course. My goal was to try to encode daily the lectures and have them available for you. It is not happening. I'm at about 14, 15-hour days right now, and that's without encoding anything. So I think my priority is going to be this weekend to see if I can take the lecture for the tutorial and see if I can get that done and get those tutorials up on the internet so that you could watch those even though you weren't here. So then that brings up the second part of that tutorial, which my goal was to have a quiz and use those quizzes as a way of seeing how you're doing on paper and pencil. Now, if I have 2/3 of the group not here to take the quiz, I may have to rethink that, and I don't know how I want to rethink that. Because I was treating that, coming back Dion to your question of the things like extra credit, that I was seeing that as an opportunity to try to work some into that. But if I only have a portion of the group who can be here because of conflicts, that's not working as well as I wanted. I need a few more bike rides to think that through and hopefully come up with a solution.
I'll that's also I wanted to ask, like, is there possibly any other time, like, because, like, there's, like, I mean, like, you know, the tutoring times after school, like,
Right.
my schedule, like for that time, too, is really bad, and I want
Okay.
I want to come at least once or twice. I want to make a commitment to at least try to come once or twice.
But the time frame
Yeah.
for the tutoring isn't, you know, I understand that that's one of the things when you start going where the whole program isn't involved with the bridge, then you have other commitments, you have other things that are happening, and the question that's being addressed, is there another time that we might have a tutorial? I think what you're going to and the answer first is, I think we can arrange something. Now the next question, what hours work? And that's what you're going to have to share with me. We know that 9 to 10 is a time you get together. We know there's a volunteer time at 2:30 to 3:30. But if there's another time we can work out, then I think we can do something. But you've got to work with me in that and let me know when it would be convenient. And it doesn't have to be everybody. But if we can get 4 or 5 people who have a different time frame that it would work well for you, then let's do it. And I'm hoping that Larita's schedule is such, and I know Brian will be supportive of it, we just make it happen. But you've got to let me know. And we're sort of doing this stumbling along the way, trying to make things work, and it's an imperfect world. But as I said to the group at 8 o'clock this morning, we survived the first week. The heck with the 30 days. We made it through the first 4, and I'm really pleased with that, given that this is completely a new thing that we're trying, and I'm hoping that with what we have going right now, that we can build on it. So if it's not working, there's something that needs to be done differently, then you've got to share that with me, and we'll make it happen the best we can. Larita.
Okay, I'm going to put a test sheet for everybody to put their contact information right now. I'll call everybody tonight, or whatever time you put on here. Indicate what time I can call you, and you'll give me your schedule, and I'll show it to Dr. Curls and set up a time.
Okay, so what Larita's asking for is just a contact information so that we can get in touch with you. And she'll give you a call. We'll get schedules set up and see if we can find something that'll work. But we will make it work. Okay, to me, that's been the crucial point of what we've accomplished this last semester. We can make it happen. Sort of like, if we tie in with what's going to happen Tuesday, yes, we can. And I think it's a good point, a good reference point. And I think one of the things you need to realize, and I told you, I have some really mixed feelings about computerized homework versus doing it in paper, and that's why the combination, I think, is in our advantage. And I know some of you have expressed a bit of frustration. I will tell you what students have reacted to this last semester, students who were somewhat negative about it at the beginning, once they got onto it, thought it was the best thing since sliced bread. So that's something to give thought to. Even though you start out feeling frustrated, embrace it, make the effort, do something about it, and see if it gets smoother. The grades do seem to improve with this process. So that's to your advantage. Now, with all that said, are there questions about the homework from section 1-3? Yes?
How much in the book and what's on the computer looks like?
Okay, the observation. The homework problem in the book versus the one that's on the computer will not be the same. That's correct. And the problem one of you does will not be the same problem somebody else does for that same problem. It randomly generates the problems. Most of the time, the problems are very similar. On word problems occasionally, there are differences that are rather major. And we'll have to be careful of that. And we'll have to make sure that we don't get blindsided by it. But for the most part, the problem you do, the problem somebody else does, are so similar, you're getting the same thing. And if you do another problem, just because you want more practice, you can try again with a different problem. And if you mess up, and I guess some of you were intentionally messing up so you could get to the next problem, then you can get, at some point, a problem that'll show you step by step what to do. So three bad solutions. Then it gets down to, here's a problem showing you every step you come down, and then you can go back and try again. That's the advantage. Yes, works it out step by step. And play with it a little bit. Okay? From the standpoint, If you can get all the problems right eventually in that set, no matter how many repetitions, you get your 100%. And that is, to me, the hook. Even though you have trouble, you can see how it should be done, you can get that 100%, and it seems to work. And as much as I personally have my reservations this last semester as it was discussed in the faculty, it is becoming widespread. Most of the algebra classes, the pre-algebra classes, the calculus class, the 121 pre-calc, all are being done with computerized homework right now. And I think, James, you more or less made the comment, it's the future. And I think indeed, and we're there. It's like I see the future and it's here. And so, much as I'm reluctant, I'm trying it. Because I think it's where things are going, and I think we benefit from it, and it's to your advantage to learn how to do that, because you take an algebra, I would guess that it's going to be computerized homework. So you might as well grab on to the brass ring right now, do the best you can, get comfortable with it, and it'll make the next course easier. Anything else on 1-3? And that would be my suspicion, that there just aren't going to be many problems. Anything you want, Dion, on that?
Yeah, I'm having a problem remembering how to work on the expanded form, like recognizing it. Like I look at it, and it's just
The expanded notation form?
Well, yeah,
or the estimation?
or just both, actually. It's just
Okay, let's go to the board on this. So, Jonathan, I'm going to have to wake you up back there. We're going to the board. And if I had, and this is just some randomly selected number. I have no idea why I wrote that number. But if I wanted an expanded form, you have two choices, correct? Either with powers of 10 or not powers of 10. So you can write 1 times 10 to the third. And I think this is what was expected in the text. And the only thing Sarah warned me about last night was that there are times where I may, for example, as I've done here, write 10 to the 0, and the text might instead want a 1. And I don't know what it accepts or does not accept at this point as far as what it may give you as a choice. Now, that is with expanded notation, with powers of 10. And I believe that was what was expected. You do have, of course, the alternate that we've talked about before, where you write it this way. And I want you to be aware that in some books, what is done is simply write 400 instead of 4 times 100. Now, I think in this book it's 4 times 100, is it not? But in the other Math 20 book, I think sometimes they did 400. So it's just, this I prefer, and that's one of the reasons why I like this book. I think it mathematically is a better book than the previous one we used. Now, estimation is a different issue. And the estimation, in terms of what is recommended when you have several numbers at the same time. So let me, as an illustration, say we had a 1427, and you were asked to add that to a 386, and you were asked to estimate your answer. The key is you look at the smallest number, and you write that with one non-zero digit. Translation, you're going to round off to this position. That means you're going to have 400. Now, the wrinkle that was causing some frustration, and we discussed this the other day, you are rounding off to the hundreds position. So that means this number should be rounded off to the hundreds position. And so in doing that, I have a 1400 plus this 400. This has 2 non-zero digits. And then that's where you're expected to get the 1800 for the answer. That you were supposed to enter, and then you were supposed to come back and find the actual answer and enter that secondly. And that seems to be where there was some glitch yesterday. By last night, Sarah couldn't make it not work, and it was sort of like, see, I told you. Yes, Marisol. 485.
And then it was like 528.
528.
So then I got confused because, or no, it was a 7 instead of a 6.
Here would be a 7?
Yeah.
Okay.
Then the 5 rounds up to a 6, and then I got
Whoa, 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 whoa. Which 5? You said the 5 rounds up to a 6. The first 5 here? Or this one?
Yeah.
You said yeah, and I pointed to both of them. Is it this one?
Yeah.
Yes on the second one. Okay, now, first, you're supposed to look at the smaller number technically.
It was like 500.
Okay, but the smaller number here is going to round off to 500. Because you rounded this off to hundreds, this should be rounded off to hundreds, so this should be 600. When you get done, you get 1100, which is 2 non-zero digits, but that's your estimate. Your turn. Okay was not what I expected to hear. Now, you were supposed to then add the two numbers. So you're supposed to take 485 and the 578, add those in the usual fashion. So you have a 13, carry the 1. You're going to have a 16, carry the 1. You're going to have 1063, which is the exact answer. This was your estimate, which tended to overestimate. Note, if both these numbers round up, and they did, then this estimate will be high. But if you have a large group of numbers, some of them will round down, some of them round up, and so you will tend to balance out pretty close. So if I've written out checks for the whole month, and I check just to see what I have sent out, I tend to round off this way. And just to get ideas, part of the time I'm up, part of the time below, and I look and say, okay, it's about this much, and that seems reasonable. Just to get an idea. But does that answer your question? Even though you still wanted to throw a brick through the computer. If it'll be of any solace to you, I have the same reactions to the computer often. And when I was sitting here the other day for an hour trying to get this machine, and I'm being polite at the moment, this machine to do something I wanted to do, which I still have not been able to do, I felt the same thing. Find a very high building and drop it. Righteous indignation. But there's some positives, okay, and that's what I'm counting on. Anything else with 1-3? Okay, are we ready to go on to 1-4? Good. So am I. Get this all to work. Now I lost my light because the electricity or something isn't working in the other room, so Debbie took my light. But here is what it's titled. Dividing whole numbers, square roots, solving equations. Now, we've gone through the whole bit with dividing whole numbers before, and there isn't a single thing that's done here that we don't do in Math 10. Verbatim, nearly. It's like reading my own work. The square roots, we talked about before, and solving equations. So let me work backwards. I want to talk about solving equations first. So as I go to the board, just a reminder. What did I just write? What is it called?
Expression.
An expression, right? As opposed to an equation. I need the equal sign for an equation. So if I said this, then I had the equation. We said, I said, you listened, but you agreed, that I can eyeball the solution. You looked at it and said, a 7 works. So you could have just told me that x equals 7, and that makes that equation a true statement. The left side is the same value as the right side. Now, we said that there is a related equation to this one. And we said you do what to get there? Well, okay, it's an arithmetic addition inverse. In essence, we add -3 to both sides. Since we haven't defined a -3 other than on the number line when we graphed, I might think of subtracting 3 from both sides. So I subtract a 3 from both sides, and I trade in the original equation for this related equation. And that's the way it's talked about in your book, and then you get your solution. Now this part, you can do in your head nearly, for this simple version. They do get more complicated. I told you that. Now here is the next equation type that we see in this section. 5x equals 15. Now you can look and tell me the solution, and it is 3, just by eyeballing it, correct? They aren't always this simple. So what is the related equation I'm going to write? Instead of subtracting something from both sides, I'm going to divide both sides. Now, I'm going to give you a new phrase, a new idea concept. This is a coefficient.
Is that one of the last two of the 11?
Moment, no. The last two of the 11, you're talking about the properties. This is a coefficient. Okay? The idea is it's the number you're multiplying the letter by. So if I have 7x, the coefficient is 7. If I have 12x, the coefficient is 12. This letter is called what instead? We had a name for it besides letter. What? Variable. Who said variable? James, okay. The variable and the coefficient, the language. Okay, I've got boxes stacked here, so I'll just lean against them. Variable and the coefficient. Part of the language you need to know. The jargon. Talking the talk. So if I have the coefficient, I divide both sides by the coefficient. So the related problem is to say x equals 15 over 5, which you then write as 3. And you solve the equation. We got it?
What was that called when you
Division. Richie's here now to talk about reciprocals. I talked about them yesterday and you weren't here to appreciate it. But the idea was the reciprocal of the coefficient is 5. Remember, that's the one of the two missing properties. For every whole number, like a 5, there is a reciprocal from Richie that is 1 over 5. So I multiplied, if you will, both sides by the reciprocal of the coefficient. Lots of language going on there.
Yeah.
But the language is rather important. Now, before I forget in this process, when I write x equals 3, remember how we talked about the unseen one? Where were the unseen ones we talked about? The no-see-ums. Well, the no-see-ums were decimals and also ones. Okay, 1 was the unseen, but where did we see it? Okay, the 3 had a 1 under it. We don't always write it. If I wrote just a 3, I could have written it as 3 to the first. Another 1 we don't see. If I have x, it's x to the first, it's x over 1, and it's also 1 times x. There's a coefficient always there, even if you don't see it. That's the one you don't see. The things you don't see become, at times, difficult because you need to see them sometimes. 1 in front of the x, even if you don't write it. And this comes back to Emily's comment about properties, because what is 1 times x? Yes, you do. It's x. I know, that was too easy. What's 1 times x? X by what property? The identity property of multiplication. You multiply 1 times something. 1 times a is a. 1 times 3 is 3. 1 times x is x. So. Solving equations. Okay, let's go back to the document, Cam, please. Square roots. When did we talk about square roots and what context? Mostly perfect squares. What was the context for perfect squares? When did we talk about perfect squares? What kind of problem were we doing? Soshi. Okay, we talked about geometry with a square. Exactly, and that's one of the things you'll find in this lesson, that a square means a figure you draw. I agree. And we talked about perfect squares. Had something to do with fractions. Primes, good. Had to do with fractions and primes. You're right. Okay. What? Oh, yes, I'm talking about prime factoring. We're getting there. This is like charades. Yes, it had to do with fractions. Yes, it had to do with primes. Yes, it had to do with prime factoring. Keep going. A big old long one. A big old long number.
Find the least common multiple.
Yes, the LCM, or more typically the LCD. How did you know whether you were done trying to factor a number into a product of primes? Okay. When you reached a number you found that wasn't divisible by anything else, but there's a lot of anything else's, so the question is, where could you stop? At some prime, yes. Jonathan, get ready to move camera 2 over to the side, please.
You gotta make sure the number's not bigger than the square root.
Okay, Michael's getting there. Something to do about the number being big compared to something.
The number squared.
Okay, there we're going. Number squared.
Those numbers that you printed out, what were they called?
Numbers you printed out. The primes? You printed out? Okay. The big primes. But if you don't have that list, when do you know you can stop? So I'm going to go to the never. Okay, while I'm walking, Maricel, go ahead. Tell me.
So you can stop when the number is the problem is
Nearly right. Nearly right. Okay, if I look at 829, and the numbers on the side that Marisol is so nicely talking about is that list of primes.
Yes.
2, 3, 5, 7, 11, 13, how soon we forget, 17, 19, 23,
and that's all I know.
and that's all you know.
No. Well, that's where we usually stop. 29.
29, okay, now.
31.
Okay, and I would say I could stop at 31. Why?
Because the square root is bigger than the number.
Okay, rather than saying the square root, we tended to look at the squares of the primes. And we said 31 squared is going to be more than 900. That's bigger than this number, so I don't have to worry about that.
That's all right.
There we go. We looked at perfect squares of the primes to know when we could stop. So if none of these work, you're done. And 829 is prime. Well, is 29 squared bigger than 829? I think it is. Let's check. Okay. We haven't done this in a while. 1 carry the 8. 26, okay. 18, carry the 1. A 5, okay.
14.
A 1, and then 14. Aha! And 29 squared is bigger than I need. So I don't need that. So all you had to do was go up to what? 23. Because 29 squared was bigger than my number. So now the question. And this isn't part of this lesson too. It's nice because this whole part goes together with what we did. What are my divisibility rules? When can I divide by 2? When the number I'm working with, this number, has the last digit even. When can I divide by 3?
When you add them all up across and they are divisible by 3.
I heard that in stereo. I add the digits, and the digits are 8, 2, and 9. The sum? 19, will 3 go into 19 evenly with no remainder? No, so 3 wouldn't divide. Rule for 5. Ends in a 0 or 5. Does it? No. So I'm done with 2, 3, and 5. All I have to do is 7, 11, 13, 17, 19, 23. If none of those work, then what do I know about 829? Prime. But notice you talked about 1 squared. Well, we didn't technically because 1's not prime. But 2 squared, 3 squared, 4 squared, etc., although we had primes. You're talking about the squares of numbers. We call these numbers, like a 4 and a 9 and a 16, perfect squares. Because we multiply a number by itself. Now that argument of multiplying a number by itself mathematically has been replaced by saying the exponent tells you how many times to write the base as a factor in the resulting product. That's good math. Again, the exponent tells you how many times to write the base as a factor in the resulting product. So when I write 3 to the first, I'm not multiplying anything by itself. But 3 to the first says write the 3 as a factor 1 time. Well, what is your product? Well, there's a missing 1. This 1 you don't see, so 1 times 3 is 3. Okay? Now, the difference is this. This is the way it's done in your text, and it's not a bad way of doing it. Fill in the box. What number goes in the box to make that a true statement? A 3, right? So we say that 3 is a number which squared would give you 9, and to translate that, we put what is called a radical sign. Now, the phrase is square root. And the R from square root looks a lot like what? The radical sign, and that's where the sign came from. So this means give me a number which, if I square it, will give me 9. 3 squared gives you 9. And this works great for the perfect squares. Marisol. Yes. And what people didn't see, and I said yes to, Marisol said, is the radical the one that goes like this? Yes. Okay? It looks like an R. Now, we've dealt with this problem before. The unit square, coming back to Soshi's square from geometry. You think of that square, 1 unit per side, so we'll just say 1 centimeter, it's too small, 1 meter and 1 meter. Bad looking square. Then, we talked about going across here. Remember Pythagoras? Pythagoras. Not quite. You're close. It has something to do with the ABCs. A squared plus B squared is equal to C squared. So if this is A, and this is B, and this is C, then we're saying 1 squared plus 1 squared must be C squared. What is 1 squared? 1. So 1 squared plus 1 squared is 2. So we say 2 is equal to C squared. But I want the square root. So C turns out to be the square root of 2. And that messed up early Greek mathematics. Because the square root of 2 cannot be written as a fraction. Cannot be written as a fraction. Now we can get a value in the calculator. You take the calculator and you'll get a 1.41 plus garbage to come. But it's not possible to write that square root of 2 as a common fraction or as a rational number. This turns out to be not a rational, which we call irrational. And that number, along with an infinite number of such values, the irrationals plus the rationals, both positives and negatives, give us the real numbers. So this square root sign becomes crucial to our argument about real numbers. Now remember, the Pythagorean theorem had some nice solutions. Remember our 3, 4, 5? So if instead of this square that Sochi gave me, I went to a rectangle, and the rectangle was 3 here and 4 here, and I draw this diagonal. Remember, this is a right angle here, meaning 90 degrees. Then we argued that 3 squared plus 4 squared must be c squared. Well, what is 3 squared? It's not 6. You're multiplying. 3 times 3, which is 9. 4 times 4. 16. Add them together. 25. So 25 is c squared. But 25 is a perfect square. So c is the square root of 25, which is 5. And so we have the 3, 4, 5 right triangle called the Pythagorean triple, 3, 4, 5. All that we've done before. So the only thing we've really introduced here, and I've introduced it before in last semester, is that radical sign. And fortunately, you're being restricted to perfect squares. You're not being asked to deal with the square root of a 2. The square root of 16, yes. The square root of 25, yes. The square root of 100, yes. But I'm not going to ask you to find the square root of 3 right now, or the square root of 7. Marisol, a half of a question. The hand went up just that much.
Okay, right there when you put a squared, b squared, and then you got the 2 at the end, the 2 equals c squared.
Okay, 2 equals c squared.
So you always have to...
You square each of these and add them.
Yeah, okay, I get that. But then you have the c equals...
Well, c squared is 2. Can you name me a number like we did with this box? Let's slide over, Jonathan, to the box. I'm saying there's something squared equals to a 2 now. There's nothing you can pick out of the air that's a whole number that's going to work. It's between 1 and 2, and it happens to be about 1.4. But it's not exactly 1.4. It's 1.41. But it's not exactly that. It goes forever. Okay, interestingly, this upset early Greek mathematicians horribly because they thought everything was whole numbers and fractions. And this is where they put the person, the apocryphal story, whether it's true or not, they put the person out on the ocean with a boat, with no food, no sails, no oars. Sort of if the gods are favorable, then you live. If not, it's because you messed with things. You now have something that's not rational. And of course, the idea stayed on and became part of the real numbers. One more comment. Coming back to this notation, let's slide over. For the moment, we are going to argue that this number inside, and it's called a radicand. The radicand. Remember, this symbol is the radical sign. But the radicand, for what we're doing, has to be a positive number right now. Has to be a positive. For now. I can't pass this up. New equation. Very good. The solution is 3 because 3 squared minus 9 is 0. Nicely done, Momaro. Okay? Okay, there was another young man, Carl Friedrich Gauss, 18, writes his doctoral dissertation. When you compare yourself to Gauss, you feel about un poquito. Okay? Very, very small. Now, he said the following as part of his dissertation, in essence. x squared plus 9 has to equal 0. That's what we are. And typically you hear the statement, there's nothing that you can add to 9 to get 0. Negative 3 plus 9?
No. Negative 3 squared.
You mean negative 3 times negative 3?
No, it's negative 3
Yeah.
divided by 3.
But negative 3 times negative 3 is positive 9.
No.
Uh-huh. We haven't talked about that, but the point is if you square a negative, you do get a positive. We've got to get to there. But my point is, this doesn't appear to have a solution. And Gauss said, that's not cool. If you have something to the second power, there should be 2 solutions. Now I'm going to come back to, there are 2 solutions here because negative 3 also works. Because negative 3 times negative 3 is 9, and 9 minus 9. There's 2 solutions here, 3 and negative 3. This, in the reals, no solution. In the reals. But he wanted a pattern. That's what mathematics is about, oftentimes. He wanted a pattern. And his pattern was, gee, there are 2 solutions here. These look a lot alike. There should be 2 solutions here. To make it happen, welcome to post-real. The imaginary numbers. Okay, and I'll leave it at that. That's, you have to wait for the algebra class for that, for the most part. But we extend our number system again. Okay? And then, just to finish up this story, 1900. Cantor. Says we can even extend it further, called the transfinites. Because it has to do with a very interesting observation coming sliding back. Okay, Jonathan, I couldn't see you, so you're behind the camera. Now, in here, we had rationals and irrationals, correct? 2 different sets. Is one more than the other? Is one bigger than the other? And Cantor said there are more of these than there are these. But they're both infinitely big. Now, these compared to the whole numbers, there are just as many whole numbers as there are these. But this is more than this. That means there's 2 different infinities. So we can have an arithmetic of infinities called the transfinites. That was just before he went off the deep end. Okay? And that question, if there are 2 different infinities, is there an infinity between the infinities? Unanswerable. 1954, Stanford University. A question that cannot be resolved. If you have the 11 properties of the real number system, it's not possible to answer that question. Now, if you add another property, then yes, you could answer the question. But then there'll be a new question you can't answer called a non-demonstrable statement. Mathematics is fun. Okay? So this whole argument that started sliding over, back to the Greek times, just trying to cross the lot. How far are you going? Ended up thousands of years later in the mid-1900s opening up areas of mathematics that we're still fighting and still working on. Okay? The real numbers is sort of a kind of stopgap. We'll make an agreement, we'll work with these numbers, 11 properties, and we don't have to hassle that. I started this morning in my 8 o'clock class with a problem I'm going to ask you to do that I've asked you to do before. Write a number on a paper. Piece of paper. All those of you sitting there with no paper out, I'm disappointed. Write a number down. Comes into your head. First number, quickly. Write a number down. Write it in your head. Got one. Okay. How many of you had a single digit? You didn't learn, did ya? Okay. Did anybody else have besides a single digit? Okay, 3 of you. We'll start with Michael. 2 digits. That's better than a 1 digit. Several of you had that. Okay, somebody go beyond that. James. Jessica. I'm disappointed. What? It's 2 digits. Anything other than that? Why didn't you use a fraction? Where's 3/4?
Because you said a number.
Oh, wow. I said a number. In your head, a number is a whole number. It should be a real number. When you hear number, the square root of 2 is a number. Yes, 3/4 is a number. You could have at least given me a big number like a Google. 3/4 is part of a 1. 3/4 is a number. Numbers are real numbers. That's the biggest message of this last hour. A number is not restricted to my grandson who says, "This is how old I am." Wrote your number in verbal notation, then you get an extra +1 for that. Robert, infinity is not a real number. It is not an imaginary number, and I'll be happy to discuss that later. Okay, but that the Greeks had to deal with. What is it? No, it's not irrational. But we'll talk about it later. I'm down to less than 2 minutes. You stay here for a moment when I finish up. I got things to say to you. Now, Jonathan, let's go to music.